Hello everyone! Welcome to an exciting exploration into the world of electromagnetic applications. I'm Nigel and today we are diving into the magic behind the vacuum cleaner. We had all used a vacuum to suck up dirt and dust, but have you ever wondered what's inside and what makes it tick? At its heart, it's all about creating airflow. And that little whirlwind inside, it is spun into life by a fan. But what actually powers this fan? Enter the electric motor. This is the superhero behind the scenes, drawing the fan blades, and in terms of vacuum terminology, it's our suction pump. Let's take a peek inside this motor. Picture it like a mini merry-go-round, where the right is a square coil connected to a ring, and this sits between two magnets. And yes, it does spin. Here's a quick GIF to show it in action. The two basic underlying principle that operates the DC motor is the Biot-Savart's law, which relates the magnetic field produced by the current carrying wire to the magnitude, direction, length, and proximity from the current and the superposition of magnetic fields. When we power up the motor and send current through the coils, it creates a unique dance of magnetic fields. The left and right wires of the coil generate their own circular magnetic fields. When these fields meet the larger magnetic field of the permanent magnet, they blend in a way that's a bit like a dance-off. On one side, where they flow in harmony, the intensity boosts, while on the other side, where they challenge each other, this intensity drops. This merging, or superimposing as we call it, results in two contrasting forces known as the Laplace forces, derived from the Lorentz force, acting on either side of the coil, as depicted in the images here. When we power up our motor, these magnetic interactions create forces that push and pull on the coil, prompting it to spin. Imagine these forces as invisible hands guiding our coil in its dance. Now, how do we know in which direction these hands are pushing? That's where the left-hand rule comes in. By analyzing the coil with our index finger, which indicates the magnetic field direction, and our middle finger, which points out the current direction, our thumb will show the forces direction. For our example, the thumb points downwards on the left side of the coil, meaning it experiences the downward forces. The opposite applies to the right side. These forces, acting together, create a twist or torque around the coil's axis, leading to its rotation. Now, back to our vacuum. When this coil spins, the rotor attached to it also turns, driving the fan. This rotation results in a powerful suction essential for our vacuum cleaners. So every time we use our vacuum, it is this magnetic dance in the rotor that helps makes our home spotless. And that's a wrap. Next time when you vacuum your room, remember the electromagnetic dance happening inside. Thanks for joining me on this journey, and I hope you see the wonder in the everyday magic of electromagnetism. Thank you.